Hi everybody. Today we're going to just take a look at constructing a unit circle. A unit circle is a tool that helps you find sine, cosine, tangent values for a lot of different angles in a very convenient way. It also gives one way to understand all of this trig stuff that we need to know with just a single visual, so it's pretty powerful and helpful. A unit circle is a circle with a radius of 1. Right? The circumference of the circle is 2 pi. On a unit circle, the circumference corresponds to the radian amount that's measured for the rotation. So for instance, if this is pi over 6 radians, that also means that the arc will be the same size. It'll be pi over 6 units in length. It's nice to know. What's important with this, though, is what's possible to tell from looking at the picture. So let's just start with this. Here's a 30-degree angle, which is pi over 6. I'm going to place this into standard position. Because the radius is set equal to 1 for every point in this picture, if the radius equals 1, that means that the sine of the angle is going to be the height of the triangle. So the sine of a 30-degree angle is 1/2, and the cosine is going to be the base of the triangle, which in this case is root 3 over 2. Normally I will record those right here, square root 3 over 2 and 1/2. Right? So when you see these points, it's because you don't really want it to be entirely cluttered with triangles. So you could draw the angle. Of course, the angle is located at the center, but the xy coordinate will tell you the cosine and sine for that angle. I'm also going to record the angle right here. That's a 30-degree angle, which is also pi over 6 in the radian measuring system. Right? So I will just do that all along the first quadrant. So here's a 45, 45, 90. And the base of the triangle is root 2 over 2. The height is also root 2 over 2. That's that medium size that we need to know. We have 45 degrees or pi over 4. Okay? So slide that out of here. You can definitely put the dotted line if you want, if it helps. Right? Here's a 60-degree angle. So the base is 1/2. The height is root 3 over 2. So the x-coordinate is 1/2, and the height is root 3 over 2. You can see the sizes of the y values. They go from small to medium to large. When we get to 90 degrees, let me finish this one up. This was 60 degrees, and this was also pi over 3 in the radian measuring system. Right? When I get to 90 degrees, the coordinate is 0, 1. That's 90 degrees and pi over 2. Right? At the point 1, 0, we're thinking of a 0-degree angle, which is also 0 in the radian measuring system. Right, so we have all of these points. The cool part about this is that all you need to do is reflect these to the other side. So for instance, here's a 120-degree angle, a rather large second quadrant angle. And, I have to get the right one here. So here's 60 degrees. And what we're getting here is just a reflected point. I'm going to take this point essentially and just reflect it over. That means that the x value, because you're moving to the left, x value is going to be negative, so negative 1/2. The y value is a positive, and that's square root 3 over 2. So it matches this one, and it should, because they have the same. This has a 60-degree reference angle, so they're going to have matching coordinate points, right? So the cool part is you can actually get the points for all of these. I mean, here's the point 1, 0. Okay, well here's the point negative 1, 0. All right, here's the point root 3 over 2, 1/2. Okay, here's the point negative root 3 over 2, 1/2. They're just reflections. So root 2 over 2, negative root 2 over 2. And then root 2 over 2 is the height. So in this part, all the x-coordinate values are negative, but all the y's are positive. We want to continue that trend. We'll do the reflection now all the way down, which will just mean all the y-coordinates will be negative. All right, so let's start here. I want to reflect negative root 3 over 2, 1/2 down, and that'll put me at this point if I reflect it straight over the x-axis. So that means that instead of 1/2, it'll be negative 1/2. So we have negative root 3 over 2, negative 1/2. So now in this quadrant, both x and y are negative because left and down are negative directions. So I'll just fill these in. It still goes small, medium, large, or large, medium, small in terms of these sizes. So this will be root 2 over 2, root 2 over 2, but they'll both be negative. Okay, and this one will be 1/2 root 3 over 2, but they'll both be negative. All right? And so you maybe want to check that. So I'm going over to the left a small amount, and I'm dropping down a large amount, so that's 1/2 and root 3 over 2. Just maybe double check those so you don't get them switched. That's the only issue. Let's see, point down at the bottom. This was 0, 1 at the top, so this is 0, negative 1. I mean, we don't really need to do that, but so I'll go ahead and fill up the rest of these. Now, fourth quadrant. Okay, what's positive in the fourth quadrant? And so, like, here's a point, root 3 over 2, 1/2. I'll reflect it down. It's still going to be root 3 over 2. It's the x-coordinate is still positive because it's to the right, but now I'm going to go down 1/2, so negative 1/2. So again, just small, medium, large, so root 2 over 2, root 2 over 2, the y-coordinate's negative. 1/2 root 3 over 2, y-coordinate's negative, but all the x-coordinates are positive. All right, so at this point we have all of these points around the circle, and if I want to put degrees and radians, and I'll just ask that you do that, I'm going to start by counting by 30s. Okay, so, you know, if you want to, you can draw these, because we're really talking about rotational amounts, you can draw these segments in so that you can be looking at the terminal edge of the angle. I mean, if I did have a 300-degree angle, it would be like all the way around here, and there's the terminal edge of the angle. I just don't want it to get too cluttered. So look at 30. Okay, so 30, 60, 90. So every 30 degrees, you basically hop the one in the middle. So the ones in the middle are usually the 45s. So 30, 60, 90, 120. Okay, hop over this one in the middle, 150, 180, 210. Okay, plus 30 gets me 240. Plus 30 gets me 270. Plus 30 gets me 300. Hop the one in the middle. We're going to go right here. 330 and 360. So, you know, just counting by 30s, I get a whole bunch of the degree amounts. And then count by 45s. Okay, so 45s are just the ones in the middle. So 45, 45, 90. Okay, 90 plus 45 gives me this one in the middle. That's 135. Plus 45 gives me 180. Okay, I don't need to write that again. Plus 45 gives me 225. Okay, plus 45 gives me 270. Plus 45 gives me 315. And, you know, they're smack dab in the middle, so 315 is halfway from 330 to 300. Okay, so you see how we did that. We just count by 30s, count by 45s. We get all of the important ones that we need to know. You do the exact same thing with radians. Okay, so here's pi over 6 radians. I put a little square around that. Okay, this is pi over 6, and we hop the one in the middle, so this right here is 2 pi over 6. And watch out, because fractions are always reduced, so 2 pi over 6, but you can divide a 2 out, and you get 1 pi over 3. So pi over 3 is what you're going to see, but it's really 2 of these pi over 6's. So 1 pi over 6, 2 pi over 6, 3 pi over 6, reduces down to pi over 2, because 3 over 6 is going to give you a half, so it reduces down to pi over 2. Next up, 4 pi over 6. All right, if I reduce that down, I can divide a 2 out, so 2 and 3, so 2 pi over 3. Okay, hop the one in the middle, so 5 pi over 6. I don't need to reduce that. 5 pi over 6. 6 pi over 6. 6 pi over 6 puts me right here. That reduces to just pi. We know that already, but you know that's how you can use your fractions. So 7 pi over 6. Hop the one in the middle, so 8 pi over 6. 8 pi over 6. 8 pi over 6 reduces down to 4 pi over 3. Okay, that's here. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. So, I mean, you could definitely show the work on that. 10 pi over 6 is 5 pi over 3, and then that's good enough. 11 pi over 6, hop the one in the middle, 11 pi over 6. And 12 pi over 6, which 12 pi over 6 equals 2 pi. 12 divided by 6 gives you 2. All right. Do the same thing with the 45-degree angle. So I know this video, it ran on long. I wanted to just have it all here so you could fast forward through it if you wanted to, or keep it for reference. But please go ahead and finish the 45-degree angle and add in the tangents for each of these. See if you can add in the tangents for each of these. And you might just put the tangent here. For instance, for a 30-degree angle, the tangent is square root 3 over 3. That's the slope of this line. You might just add that here to have it in your reference. Okay, and some teachers also add in ASTC. That's not a bad thing to have also. Okay, so there you go. You finish that up. Add in the tangents. Add in the pi over 4 increments all the way around the circle, and we'll start using it.